So I'm doing this. It's at the end of week 7, right after we finish chapter 6 with the normal curves, and we're talking about that binomial the binomial normal approximation, the binomial distribution in chapter 7 or in chapter 6. And one of the conditions we got to meet in order to make sure this is true is if it's a normal distribution, because if the binomial experiment is not a normal distribution, we can't use normal tools on it. So something that gets glossed over, and I mean, WebAssign doesn't stress this. Textbook does somewhat. It's going to be more important after this exam week, and we get into week 8, week 9, when we start talking about confidence intervals. It, in order to have a in order to have a normal distribution, be able to use a normal curve of the binomial distribution, this has to be true. And basically, it's your sample size times the probability of success. You multiply that has to be bigger than 5. Some books say 10. Either way, it works. Five is often close enough. And then the Q is the one minus the probability of success. And what I want to do, and he talks about it a little bit up there, right? So that also has to be bigger than 5. If these conditions aren't true, then it's not going to be a normal distribution. And what I want to do is I walk through a couple of examples here and show you. And one of the tools that I give you folks in modules, the course resources, if you see that online statistical tools, this is a collection of web pages, applets that can do some of this work for us. And the one I'm going to point you towards right now, it's great for the graph. I tend to use this is that GigaCalc binomial calculator, but this histogram applet works pretty cool. And so suppose I've got a sample size of 20. I've got a probability of success of zero point 0.2. I'm sorry, zero point 0.8 is one I wrote up. And then I'm just going to have a graph that. See how that is a left skewed distribution? So shouldn't be using the mean and the standard deviation to describe it. It's not a normal distribution. So that in that case, if we were having to find binomial probabilities, we'd have to go use that GigaCalc calculator. This one here, yeah, and there's other ones too. Your graphing calculators do it. This one's nice because it does it all. I could say what is the probability is zero point 0.8, I said, and n's 20, and what if I wanted to do exactly 5 and calculate? And this, yeah, the calculator here, that's exactly 5, so it's pretty small probability. How about less than 5? Well, that adds up the probability for 5, 4, 3, 2, 1, and 0. So it works pretty well. And it works. So this is what we're going to use if we don't have a normal distribution. So we gotta check that it's a normal distribution. What if I crank this up to 200? Oh, maybe I should do that condition check. Show you how that greater than 5 thing works. Here, let me get a pen going. So it says 20 times zero point 0.8 has to be bigger than 5. Well, let's see. This is 4/5. I could grab a calculator, but I'll do it since it's a nice number. 4/5 times 20. I don't know, maybe doing this fraction review will help you out. 5 goes into 24 times 4 times 4 is 16. So yeah, that's bigger than 5. And then the converse of that, we have to multiply by zero point 0.2. We have to say that's the Q. And then zero point 0.2, so 1/5 of 20 is exactly 5, and the condition was more than 5. So because it didn't pass that condition, we don't have a normal distribution. Okay, and we really shouldn't be using the mean and standard deviation. Okay, so remember it said it has to be bigger than 5, and this is equal to 5. So that would be, if they had this, would be good, greater than or equal to, but we didn't. Anyway, a little algebra. So what happens if here, let me clear my writing. What happens if I made this be 200? Now, I won't type in the answer until we check it out. So 200 times zero point 0.8, well, I think that's 160 because I've just multiplied it by 10, right? And 200 times zero point 0.2 is 50. So both of those are bigger than 5. This should be a normal distribution. Let's see if it is. Let's clear this out. Let's type in here. I'm going to type in 200 and then have a graph it. And sure enough, that looks like a pretty normal distribution to me. Okay, so you see that's how it works. If you get a big enough sample size, you can apply that normal distribution. This is one of the things I was hoping to see on week six quiz, with the one we had to talk about. Some of you had jawbreakers, some of you had I don't remember what the word, a television station news service, that kind of thing. Nobody checked it. That's okay. I mean, I'm not worried about it. When we start working on chapter eight with with in chapter seven, when we do confidence intervals and hypothesis tests, it's something I'm going to be looking for you to check. Okay. So hopefully this helps. It doesn't confuse you. Let me know if you need some help.